Okay, as promised, this is the video where I'm going to show you how to solve some of those trajectory at an angle problems. And so, no, we are not solving your problems psychologically. I don't get paid enough to do that. But this will help you for your test on Friday, and then you can watch this video as many times as you want or as many times as you need to prepare for the test or to really get this how to solve these kinds of problems down. And I'm only going to show you one kind of problem, but switching to another problem is just algebra. That's all it is. If I give you different variables and to solve for different things, all you're using is algebra. So, but showing you how it works, I think is going to really help, and then we'll practice this on our review day. So, solving problems at an angle is just like solving problems of horizontally launched objects. Okay, so here are our tips. We're going to separate the x out the x and y givens, and that's because the horizontal and vertical components are independent of each other, that they don't relate. Okay, the y givens give us like a throw-up problem, like a ball is being thrown up in the air and it lands. Okay, and then the x givens are going to give us a one-dimensional motion problem, which is like when v is constant. Okay, remember that the time will be the same for x and y, and then this is a new thing, is that the y velocity will be 0 at the top, and the x velocity is the same for the entire time. But the fact that the y velocity is 0 at the top is going to pretty much be a very key factor in us calculating stuff. So let's take a look. Okay, example 1. A football is kicked with an initial velocity of 25 meters per second at an angle of 45 degrees with the horizontal. Determine the peak height of the football, the time of flight, and the horizontal displacement or range. So first of all, we're going to draw a picture. Here's me kicking a football at 45 degrees, going 25 meters per second. So remember, that's our vector. It's 25, and our angle is 45. Okay, and this is what we expect to happen to the football. Okay. So in the problem, we are going to try to find peak height, time of flight, and horizontal displacement. So when I draw that on my picture, I'm going to get this. I'm going to have height, I have time, and I'm trying to find horizontal displacement, which is how far it goes, which is the range. So, like everything else, I have to make an x and y chart because x and y are independent of each other. Okay? So the first thing I'm going to do is, well, I know in the y column, I have acceleration is going to be negative 9.8 because of gravity. Okay? Notice that we put negative 9.8 this time instead of positive 9.8. The horizontally launched problems, like the marble off the table, the marble is always moving downward, so I'm going to say positive 9.8. But in this case, we are not moving downward. We are going up and down, so I'm just going to be safe and call gravity negative. Okay, so these are the ones I'm trying to find. X is obviously going to go in X, height is going to go in Y, and then the time for both are going to go in both columns. Okay, so here's the thing. We also know that the initial velocity is 25 meters per second, right? But remember that that is in both X and Y. You have to find his two personalities, the part of him that's the horizontal part and his split personality that's in the Y part. And if you remember from your notes, we said that the horizontal component, v naught x, is going to be equal to v times the cosine of that angle. Because cosine trigonometrically gives you the adjacent side, which is the x horizontal part. So when we plug in our numbers, we have 25 times cosine of 45, and that gives us 17.68 meters per second. So I'm going to write that into my givens chart. Okay. Similarly, Vy at the beginning is going to be related to the sine of the angle because sine gives you the opposite, and opposite is the vertical component. So when we plug in our numbers, 25 times the sine of 45 gives us 17.68. And so I'm going to go ahead and copy that into my chart. Okay. So now I have every given that they've given me, every given that I know is now in my chart. And I need to solve for x, h, and t. Okay? So first, we're going to look at peak height, which is h. Okay? So something that, okay, so the key fact that you have to know in order to find height, the key fact is that at the height, that's that little red X, the final velocity in the y direction is 0. So v sub Fy, like a little f, little y, equals 0. The final velocity in the y direction, it stops at the top. So that means I have Vf, V naught y, and A, and I want a distance for height. So that means my equation that I'm going to use is Vf squared equals V naught squared plus 2AD. It's the easiest one. Okay, so using a little bit of math and magic in the algebra, it is left to the reader to show that to solve for distance mathematically, you get this equation after you do all the algebra. Okay, so when we plug in Vf equals 0, V naught y equals 17.68, and A is negative 9.8, then we get this. Okay, plugging into our calculator and hitting enter, I find that the peak height is going to be 15.95 meters tall, which sounds reasonable. If I kick a football, 16 yards in the air sounds reasonable, so I'm going to go with it. Okay, so in my chart now, I'm going to replace h with 15.95 meters. Okay, so I'm going to move on to time now. So the second thing we need to find is time. So when I look at my t-chart, x and y, y is pretty filled out now. And the only thing I don't know is time. And so that means I'm going to be using time to figure out, you guessed it, how high it goes. So I'm just going to use this equation because I know my final velocity at the top of the peak is 0. Again, this is only looking in the y column. I know my final velocity at the top of the peak is 0. I know my initial velocity is 17, and I know acceleration is negative 9.8. So when I plug this in, when I solve for t algebraically, I get Vf minus V naught divided by A. And then when I plug in my numbers, I'm going to get 1.8 seconds. Okay? So this is also a little side thought. If you use our traditional time equation, t equals the square root of td over a, you would have gotten 1.8 as well if you had used 15.95 for d because it's our height. So that's also an alternate way that you could have done that. Okay, but here's the deal. 1.804 seconds is only the time to the top right here where Vfy equals 0. So that means I'm going to have to multiply that time by 2 if I want the whole thing, because that's technically just the time it's going to take to get to the top. And so if I want the time to come back down to the ground, I have to multiply that number by 2. And I'm going to get 3.6 seconds. So, filling that in my time on both sides, now I can finally move on to range. Okay, so now when I look at range, range is obviously an x horizontal part. So when I look in my x column, I only have one question mark, and I have t and v naught x. So that means I'm going to use v equals d over t. And of course, these are in the x direction, so that's why that x there comes into play. Okay, so solving for d, I get v times t, and then I plug in my numbers, and I get 63.6 meters. And this is exactly what you did today or yesterday in your lab when you solved for the range of your marble once it launched off the table. So I'm going to put that into my t-chart. So I have now completely solved this problem. I have determined the peak height is 15.95 meters. The time is going to be 3.6 seconds, and the horizontal displacement is 63.6 meters. So that is all exciting and good. So here is a practice problem. I am not going to work it out for you, but I will tell you the answer. So a ball is launched into the air at an angle of 32 degrees with an initial speed of 18 meters per second. Neglecting air resistance, determine how high the ball will go, how long it will be in the air, and how far it will travel. So the same questions again, and you know that you are going to go 18 meters per second, and your angle is 32 degrees. Okay, So you got to find all that stuff for the same trajectory. Okay? Once you figure all that out, you can pause this video, try it, go home, take a nap, and then try this. But whenever you are done, you should get 4.64 meters for the height, 1.95 seconds for the time, and 29.7 meters for the range, or horizontal displacement. Okay, so that's the end of this video. We are going to talk about this more when we review in class. If you have me second period, then that means you will not see me for the review day, so you need to make sure that you come and grab your review and ask me any questions about this video before Friday. Okay, and that's all I have. Good night and good luck.